Hey y'all, thank y'all for being good today. Listen carefully and let's go through how to do this. So we're going to start here. This time we're doing combinations and transformations or linear combinations. So the first thing we're going to do, it says you're playing a game in Statland in which you must spin the two spinners. So what I want you to do is find the mean and standard deviation of spinner A and do the same thing for spinner B. Pause the video at this point. Do those as you can. I'm going to take a second and do them. And put those in my calculator and let's do the calculations. And for spinner A, we got the mean of 3.5. And for the standard deviation, and we're using the sigma, 1.708. And now for spinner B, we got a mean of 2.5 and a standard deviation of 1.118. Okay, so now let's list the possible sums of the two spinners. So across the top, this is spinner 1, or spinner A. And going down, this is spinner B. So if we do the sums, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5. And do that with all of them. So 3 plus 1 is 4, then 2 is 5, 6, 7, 4 plus 1 is, so we're going to start at 5, 7, 8, we're going to start at 6, 7, 8, 9, 7, 8, 9, 10. Now take a moment, type that into stat edit, find the mean and standard deviation. You might need to pause the video at this point so you get a moment to find the mean and standard deviation. And actually, and when I calculate it, the mean comes out to be 6 of A and B, and the standard deviation comes out to be 2.04. 1. Sorry, I forgot the 1. Okay. What do you notice about the mean and the standard deviation? Well, on the mean, let's put it in. The mean, if we look at it, mean of the sum, which would be mu of A plus B, is the same as the mean of A plus the mean of B. The standard deviation, now this one's harder to get. So I'm going to give this one to you. So the standard deviation is the square root of the sum of the variances. Ooh, that's hard to read right there. Okay, so what that means is that for this one, it is the square root of the standard deviation of A squared plus the standard deviation of B squared. Okay, so suppose in one version of the game you had to move the difference of spinner A and spinner B. So you're going to do A minus B. So when we do this problem, we are going to go, oh, hello. Let's see, stop. Okay. We are going to go here and across here. And this is 1, 2, 3, 4. And this is 1, 2, 3, 4, 5, and 6. And actually, well, it'll be fine. Okay, so let's fill this in. So 1 minus 1 is 0. 1 minus 2 is negative 1. 1 minus 3 is negative 2. And it's negative 3. 2 minus 1 is 1. 2 minus 2 is 0. Negative 1, negative 2. 3 minus 1 is 2. 3 minus 2 is 1. 3 minus 3 is 0. 3 minus 4 is negative 1. 4 minus 1 is 3. 4 minus 2 is 2. 4 minus 3, and so on. So this is the pattern we're doing. 5 minus 1 is 4. 3, 2, 1. 5, 4, 3, 2. So if you make a prediction about now, I hope you get it right. But we are going to enter this. This is a time you might need to pause. I'm going to put all these numbers into stat edit. And I am going to calculate my mean and standard deviation. And for my mean, I got 1. And for my standard deviation, I got 2.041. What do you notice about your mean and your standard deviation? Well, the mean of the difference which would be mu of A minus B, is the same as mu of A minus mu of B. Now look at the standard deviation from the problem before and this one, and notice how they're the same. So the standard deviation is the square root of the sum. Notice it says sum, so that means they're both the sum of the variances. And y'all, all variances is the standard deviation squared. So again, that formula is going to be standard deviation of A minus B is equal to the square root of the standard deviation of A squared plus the standard deviation of B squared. Okay, rules. Just like yesterday, we wrote rules on what we wanted to say. So, to find the mean for the sum or difference you were going to do mu of A either plus or minus B is equal to the mu of A plus or minus the mu of B. So notice if the top is positive on the left, it's positive on the right. If it's minus on the left, it's minus on the right. For the standard deviation, and I did not leave y'all a ton of room, I apologize. To find the standard deviation, always add the variances and square root. And I'm going to put my equation up above here. And let's actually change colors on both of these. So they stand out a little bit because it's hard to see them. So for this one, I'm just rewriting. So this one was mu of A plus or minus B is equal to the mu of A plus or minus the mu of B. It's going to be one or the other. And for variance, for standard deviation of A plus or minus B, it's going to be the same equation regardless. And it's going to be the standard deviation of A squared plus the standard deviation of B squared. And square root that. So let's do an example over here. Okay, it says bicycles arrive at a bike shop. Before they can be sold, they must be unpacked, assembled, and tuned. Based on past experience, the times for each setup phase are independent with the following means and standard deviations. What are they? Okay, so we're going to do, it says, what are the mean and standard deviation for the total bike setup times? When you're doing total, you're doing sum. So this is the mean of, we're going to call this U, A, and T. Let me move those over a little bit. U, A, and T. So that's the mu of U plus A plus T. So that's going to be, the mean of U is 3.5. The mean of A is 21.8 and the mean of T is 12.3. So that means for a total, our mean of U plus A plus T is 3.5 plus 21.8 plus 12.3 is 37.6 minutes. So there's the first half of what we asked for. So the second half, we're going to do standard deviation of U plus A plus T. So that is the square root of the standard deviation of 0.7 squared plus 2.4 squared plus, I'm going to run out of room, 2.7 squared. I'm going to type that in the calculator just like it looks. And I get that the standard deviation of mu plus A plus T is 380 minutes. Okay, so let's continue on and let's see if we can do. So student A is curious of the number of cars a family owns for different teachers at a private school A versus school B. The student gathers responses from eight teachers in each school, and here's their responses. The student starts by finding the mean and the standard deviation. So let's do that really quick because that's easy. 1 plus, or 2, 2, 3, 3, 4, 4, 5. 2, 3, 4, 5, 6, 8. So stat calc, let's do list. So our mean over here is 3. Ooh, hello. Is 3, and our standard deviation is 1.225. And let's do the other one really quick. And our mean is 4, but this time our standard deviation is 2.121. So our data is more spread out. It appears that the families at school B have more cars than at school A. But how many more on average? The student wants to know if the mean difference is what the mean difference is between the number of cars per 2 schools. They know they must find each possible difference in number of cars before. Okay. Well, we spent all this time working on that, so let's use the rules. So I'm going to put a little note. We are going to use the rules. And the rules say that we want to do school B minus school A. So that says mu of B minus A is equal to 4 minus 3, which is 1. So the average difference is 1 car. And the standard deviation of B minus A is the standard deviation of 2.121, which is B squared plus, it's always plus. I'll make a note, always 1.225 squared. So let's do the math on that. And we get that is 2.449 cars. What relationship do you notice? Well, friends, it's the same relationship we've been talking about. It is this one that is mu of B minus A is equal to the mean of B minus the mean of A. And for standard deviation, it is, I don't want that X there. I want B minus A. It is the standard deviation of B squared plus the standard deviation of A squared. Again, it's always plus. Sorry, I misunderstood what they wanted. And actually, this one needs to go lower, but it's okay. Let's go back to here. So this would be, y'all, it's the same thing we just did because we used the rules. Is equal to 4 minus 3, which is equal to 1. For standard deviation, it is, just like we wrote a second ago, b minus a is equal to the square root of the standard deviation of b squared plus the standard deviation of a squared. Which, to show it, is the same thing as saying standard deviation of b minus a is equal to the square root of, what was that? 2.1 to 1 squared plus 1.225 squared. Okay, summarize those relationships. Y'all, it's obviously, we have written it 3 times. So a plus or minus b is the mean of a plus or minus the mean of b. If we have written it this many times, then it is seriously important. So this is one of those things where, like, when you get to college and your prof says it, writes it, does all the things, then you really need to pay attention. This is one of those cases. Okay. Would the difference in means and standard deviations happen? In means and standard deviations be different if they went from A minus B? Explain. Well, yes. Mean would be greater, or no. What would it be? Mean would be different, but the standard deviation would stay the same. And that is because the formula for that standard deviation is plus. Again, we are going to take this moment and we are going to use the rules. So let's do that. So for mean of A plus B, that is going to be 3 plus 4, which I am going to put down there, which is 7 cars. And then the standard deviation of A plus B is equal to the square root of 1.225 squared plus 2.121 squared. And that works out to be 2.449. Again, the relationship is the formulas. Mu of A plus mu of B is equal to mu of A plus B. Standard deviation of A plus B is equal to the square root of the variances. So you should feel like all we are doing is asking the same thing over and over and over again. Okay, what relationship do you notice about hold on, where are we? Oh, y'all, I did this. This one goes here. Dang it. And then This one needs a, sorry y'all, I just keep a plus b is equal to 3 plus 4, which is 7. Here, standard deviation of a plus b is equal to c above. We did this already, but I'm going to rewrite it again just because I want it absolutely stuck in your head what these formulas are and what we are using them for. And that this is standard deviation. And that on standard deviation, it is always plus. Okay. Summarize the relationship with formal rules. I'm going to just put a note. Use the formulas. This is one of these two formulas are one of the too few that would, that you are given on your final and will be given on your test and on your quiz. Okay, it said, would the sum of the means and standard deviation be different if the student instead found the sums? Well, 4 plus 3 is the same as 3 plus 4, so no. Addition is commutative. Okay, so combining two we are going to do mu of a plus or minus b is equal to mu of a plus or minus mu of b. And then for standard deviation of a plus or minus b, that is the square root of the standard deviation of a squared plus standard deviation of b squared. I'm going to put a little rules review. Not there. Let's do a little line down here. Add constant. And that does, let's see, for mean, that is mean plus constant. And for standard deviation is equal to the standard deviation. If I want to multiply a constant, and actually I'm out of room in this box, so we'll just put it outside. When you multiply a constant, your mean is equal to the mean times the constant. And the standard deviation is equal to the standard deviation times, you put a time sign in there, constant. Okay, I hope with me beating you over the head with these two formulas that you get the idea, and then these two additionally will help with the other things that we have focused on. So far, this is the summary of everything we have learned. I will see you on Wednesday. Have a